Hello and welcome to Learn with Isa. Over 3 decades of working across multiple continents, I have seen defense and aerospace technology evolve from manual observation posts to fully autonomous AI-driven surveillance ecosystems. In today's fast-moving world, seconds matter in threat detection. Whether it's monitoring airspace violations, tracking maritime intrusions, or protecting ground assets. Real time AI powered identification and classification is no longer futuristic, it's operational reality. Today, we will explore how AI integrates with multi sensor defense systems, the technical underpinnings of real time detection and classification MIL STD compliant architectures for mission critical environments. Traditional radar or surveillance systems often face have false positive due to environmental noise, delayed detection because of manual confirmation workflows, also limited scalability when monitoring multiple domains simultaneously. AI addresses these challenges by using computer vision to detect and classify objects in milliseconds. Applies sensor fusion to combine radar, infrared, and optical feeds for higher accuracy. Also enabling autonomous decision support, allowing human operators to focus on strategic actions only. Also, the core technologies which we can use during implementation of these kind of systems involves real-time object detection through YOLO V8 model. We can use YOLO V8, you only look once, version 8, processes frames in real time, critical for aerial, maritime, and perimeter security. Also, pre-trained weights can be adapted with transfer learning for defense-specific classes like UAVs, armored vehicles, or maritime vessels. Low latency inference possible with NVIDIA Jetson hardware on the edge. For signal processing and feature extraction, radar and sonar feeds undergo fast Fourier transformation, FTT, for spectral analysis. Signal to noise ratio, SNR optimization, ensures high detection probability in cluttered environments. Also, sensor fusion is quite critical part over here. Combines multiple sensor modalities, EOIR, electro-optical infrared, radar, and LiDAR. Also, Kalman filtering and Bayesian fusion algorithms synchronize data streams for a unified threat picture. What are key data sources which we can use? We can use optical cameras for high-res visual data. We can use thermal imaging for night or obscure visibility. Then radar arrays for long-range detection under adverse weather conditions. So how AI workflows work over here? First of all, we need to capture edge data. Through cameras, radar units, and IR sensors, feed data into an onboard processor. For example, NVIDIA Jetson Xavier NX. Then we need to do pre-processing through OpenCV pipelines for frame stabilization, noise reduction, and contrast enhancement. We also need to do inference and classification through YOLO V8 model detects and tags subject objects in less than 50 milliseconds. Then multi-sensor correlation is also an important aspect, where we can sensor fusion layer validates detections to reduce false positives. Also, command and control integration as well. Threat classifications transmitted to command and control. C2 in MIL-STD 1553 or MIL-STD 1760 compliant formats. So there are different tools and frameworks which we can use, but generally we can use YOLO V8 for real-time high-accuracy object detection, OpenCV for image pre-processing and feature extraction, NVIDIA Jetson for edge AI acceleration under low-power ruggedized condition, and then MIL STD architectures for interoperability and reliability in defense systems. Then ROS, Robotic Operating System, for autonomous navigation and control logic integration. Let's talk about global case applications. For coastal monitoring, we can there are different organizations detecting unauthorized maritime vessels in Singapore Strait. For aerial defense, identifying and classifying UAVs in European no-fly zones. And for border security, multi-sensor parameter surveillance in Middle East desert terrains. So what are the best practices in compliance which we need to take care in order to implement that kind of sensitive systems? We need to take care of latency minimization, need to optimize pipeline for sub 100 millisecond detection to allow time. Also redundancy, failover sensors and dual model inference pipelines. Adversarial robustness needs to be taken care properly. We need to train models against spoofing or camouflage attempts. Then MIL STD compliance is important. Ensure interoperability with NATO and allied systems. And ultimately, ethical AI governance is strict adherence to IHL, international humanitarian law, and defense ethics protocols. Defense and aerospace environments demand absolute precision and uncompromising reliability. AI-powered threat detection doesn't replace human judgment. It amplifies it, allowing defense teams to act faster, with higher confidence, and across multiple threat domains simultaneously. If you'd like me to create a full architectural diagram showing how YOLO V8 sensor fusion algorithms and MILSTD command protocols integrate into a real-world autonomous surveillance drone system, let me know in the comments. And remember, in defense, technology is not just about innovation. It's about preservation. Now, don't forget to hit like, subscribe with London Asia, and have a nice time ahead. Thank you.